Hello, my name is Bob, and once again I'd like to welcome you to another episode on the White Dog Garage YouTube channel. This video is going to be another in my metalworking videos. It's going to be a machining video, but a relatively simple one, but you might find it interesting. In America you might call this, I think, a Hayman video. Here in Australia it ends up more like, mate, can you do a little job for me? Anyhow, what it's about is I have to machine some bushes for two little cast iron wheels. Now they've already got a bit of a bush in them and a bit of an axle, but the client wants them to run a bit truer. There are a number of ways of doing this, and I'm going to show you what I did. You can find a piece of pipe that fits. It came with a piece of pipe that fits. Or you could machine a bush to go inside the hub, and that's what we're going to do here. Now, there are a number of ways of fixing that bush, or you could let it run, but this is cast iron and you don't necessarily want it to run because eventually it's going to wear. So what I'm going to do is I'm going to put a brass bush in the centre and I'm going to fix it in place with an interference fit. That is, the diameter of the bush is a little larger than the diameter of the hole it's going into. There are other ways you could do this, of course. You could use a gib key, but cutting a keyway is more time than I want to take. The other alternative is to fit what's called a Scotch key. The issue here is that the Scotch key is just drilling a hole essentially and fixing a key in place, a round key. But again, that's a bit more work and I want to keep this pretty simple. So I'm going for a straight bushing, a press fit, slight press fit, because this is cast iron. Cast iron's good in compression. That means take a lot of weight across the wheel. But what it doesn't like is tension, which would be a lot of pressure outwards. It's going to be a good press fit, 0.0508 millimeters, 2 to 3 thou oversize of the shaft, pressed into the centre, and then the axle hole, or the hole for the axle, drilled in the centre of that again. I hope you find it interesting and I hope you follow along. I start by machining the wheel centre, but first I wanted to check the run out. I find it's not too bad, considering that these are well used, cheap cast iron wheels. I used a small boring bar to machine the centre. I fitted this bar with a high-speed steel bit, which, with the right speed, will work fine for cast iron. Cast iron machines well, but the swarf is difficult to clean out and can damage the latheways, so I'm laying a cloth on the bed to catch the bulk of the turnings. Moving the boring bar up to the wheel centre, I wanted to remove the minimum amount of material to give a concentric hole to the wheel rim. I'm trying to keep the amount of cast iron turnings lying around to a minimum, so I'm regularly cleaning the tool off. It takes more than one pass to machine the wheel centre to be perfectly round. Once I'm happy with the centre of the wheel, I move the boring bar back out of the way and then use a telescopic gauge and micrometer to determine its exact diameter. I'm only showing one measurement here, but I actually repeat the measurement a number of times and take the average. Although I'm not showing it here, I'm doing two wheels, so knowing the final position of the cross slide for the first one, I then machine the second wheel centre to the same dimension. With the wheel centres done, I then moved on to machining the two brass plugs that will be used to form the actual bushes. I'm using a length of brass round for this, and I start by using a centre drill to form the mounting point for the live centre that will support that end. With the end supported by the live centre, I then machined the diameter of the bush to enable a press fit into the wheel centre. That is 0.05 to 0.08 millimetres, or about 2 to 3 thou oversize. I use a rule to make sure the bush is long enough to stretch from one side of the wheel to the other, and I stop a couple of times to make sure I am on track to finish at the desired diameter. Before I remove it from the lathe, I put a slight bevel on the machined end of the plug to act as a start point, pressing it home. Although I could have parted off the plug on the lathe, it is quicker and easier to do it on the bandsaw. Viewers will notice that I have left the lip on the bushing blank. This both acts as a stop for the press and provides more surface adhesion when the plug is drilled out to take the new axle. It will be machined off when the wheel is finished. I am using a 2-ton arbor press to press the plug into the wheel centre. As mentioned previously, cast iron does not deal well with tensile forces, and the plug is essentially expanding the wheel centre, albeit at a very small amount. If I needed a heavier press to do this, the interference fit would probably be too great and the wheel centre would likely crack or shatter. With the plug pressed home, it is back to the lathe. First, I face off the plug end flush with the front of the wheel hub. Then I swapped the wheel side and proceeded to drill out the centre. As I mentioned previously, I've left the lip on the plug intact. This was intentional to provide an additional contact surface for the plug to the wheel centre, preventing any rotational slippage as the hole is drilled to suit the new axle. I start with the pilot hole and follow up with the drill to the final diameter. The axle fit is not that precise for this job, so simply drilling out the centre does the trick without having to resort to a reamer. With the hub centre drilled out, I locked the saddle and manually fed the tool using the cross slide to face off this side of the wheel. The second wheel is an exact copy of the first, and the two wheels were ready for their new life.